Hey guys, Mr. Backberg here. In this video, we're going to look at solving quadratic equations by completing the square. So when we're looking at the standard form of a quadratic equation, that's going to look something like ax squared plus bx plus c equals 0. And one strategy that we've used earlier on this year is factoring, but not every quadratic equation is factorable. So we need to have another strategy available to us to be able to solve these equations. And that's where completing the square is going to come into play. Now, one big rule with completing the square is we need to make sure that our a value, the number in front of that x squared, is just a 1 before we get started. And then what we want to do is we actually want to take that c value, that constant term on the end, and we're going to move that over to the other side. Now, since our a value is 1, we don't really need to keep it on there. So then our equation would say x squared plus bx equals negative c, and I left that space in here for a reason. To complete the square, what we're actually going to look at is this b value, and we're going to take our b value, divide it by 2, and then square it. And whatever answer we get, we're actually going to add in here in our equation, and that's going to create a nice factor set for us. But we can't just add it to one side without throwing the balance of our equation off, so we also need to add that b over 2 squared on the right-hand side as well. And then, like I said, we're going to be able to factor out the left-hand side really nicely, and then actually use our square root property to finish solving this equation. So let's look at an example in here. Let's say we had the equation x squared plus 8x plus 10 equals 0. Now we could look at this and we could try to factor it, but there's no numbers that are going to multiply to 10 and add up to 8. So we're going to use our completing the square. So the first thing we need to check is that our a value is 1. There's no number in front of this x squared, so we're good. I'm going to take that plus 10 and subtract it over to the right-hand side. So we get x squared plus 8x equals negative 10. And again, I left that space in there for us to be able to complete the square. So I'm going to look at my b value now. I'm going to look at this 8. And I'm going to take 8 divided by 2, but then square that. So 8 divided by 2 is 4, and 4 squared is 16. So I want to add in this 16 on the left-hand side, but I can't just add it on the left-hand side. I also have to add it on the right-hand side. Now what that's going to do for us is that's actually going to create a really nice factor set on the left-hand side. So if we think about things that multiply to 16 and add up to 8, it's going to be x plus 4 and x plus 4. Now since we've got a repeated factor, we can shorten that to just be x plus 4 squared. Now on the right-hand side, we're going to be able to combine the negative 10 and the 16 to get 6. And now what we can do from here is use our square root property. So to get rid of the squared on this set of parentheses, we can square root both sides. So then we would get x plus 4 equals plus or minus the square root of 6. Now I'm going to split up these equations. So x plus 4 equals the positive square root of 6, and x plus 4 equals the negative square root of 6. If I subtract this 4 over to the right-hand side, then I'm going to get x equals negative 4 plus root 6. And if I subtract this 4 over to the right-hand side, then I get x equals negative 4 minus the square root of 6. So those are our two answers in this case. Now let's practice that again. Let's say we had the equation x squared plus 6x minus 3 equals 0. First thing we want to check is that our a value is 1. It is, so we're okay. I'm going to add that 3 over to the right-hand side, so we get x squared plus 6x equals 3. And again, I left that space in there. I'm going to take that 6, divide it by 2, but then square it. 6 divided by 2 is 3, squared is 9. So I'm going to add the 9 here, but I also have to add the 9 on the right-hand side. I'm going to create my set of factors in here, multiplying the 9 and adding up to 6. I'm going to need x plus 3 and x plus 3. But again, because this is repeated, we can shorten that to be x plus 3 squared. On the right-hand side, if we add those together, we're going to get 12. Now I'm going to square root both sides in order to get rid of that squared on my parentheses. So we've got x plus 3 equals plus or minus. Now I'm going to break down that square root of 12 using a factor tree. So the square root of 12 can be split into 4 and 3. But 4 can be split into 2 and 2. So we got a pair of 2's and an unpaired 3. So this is 2 root 3. I'm going to split up my equations. So x plus 3 equals the positive 2 root 3. And x plus 3 equals the negative 2 root 3. Subtracting that 3 over in my first equation, I get x equals negative 3 plus 2 root 3 as my first answer. And if I subtract that 3 over in my second equation, then I'm going to get x equals negative 3 minus 2 root 3 as my second answer for this equation. Now we're going to look at one more example in here. Let's say we had the equation x squared plus 2x plus 7 equals 0. I first check to make sure that my a value is 1, and it is, so we're okay. I'm going to subtract that 7 over to the right-hand side, so we get x squared plus 2x equals negative 7. When I do my completing the square, I look at that 2, I divide it by 2, but then I square it. 2 divided by 2 is 1, 1 squared is 1, so I add 1 on the left and I add 1 on the right. On the left-hand side, I'm going to create my factor set. To multiply to 1 and add up to 2, we need x plus 1 and x plus 1. We'll shorten that to be x plus 1 squared. On the right-hand side, if I combine negative 7 and 1, I get negative 6. Now, when I square root both sides, I have to be careful on the right-hand side because now we've got a negative 6. So the left-hand side is going to be x plus 1. The right-hand side is going to be plus or minus I root 6 because of that negative 6 underneath my radical. Now again, I'm going to split up my equations. So I'm going to have x plus 1 equals the positive I root 6. And then I'm going to have x plus 1 equals the negative I root 6. If I subtract that 1 over in my first equation, I'm going to get x equals negative 1 plus I root 6. And if I subtract the 1 over in my second equation, I'm going to get x equals negative 1 minus I root 6. So those are my two answers this time. That's going to be it for this video. Thanks for watching.